My dear students, in the previous video, we have seen the properties of determinants. That is, up to 4 properties we have seen. In this video, I am going to derive property 5 and property 6. The first 4 properties we have seen already. Before going to see the 5th property, there is one remark for the property number 4. Remark for the property 4, that is, if any 2 rows or columns of a determinant are identical, then the value of the determinant is 0. That is the property 4. If any 2 rows or columns of a determinant are identical or the corresponding elements are one and the same, if it is the case, we have seen the determinant value is 0. And this property, there is one remark, that is, if any 2 rows or columns of a determinant are proportional, any 2 rows or columns of a determinant are proportional, then its value of the determinant is 0. Example, consider the determinant 5 minus 10, 15, 1 minus 2, 3, 4, 0, 7. Here, R1 is 5 times of R2. R1 and R2 are proportional. R1 and R2 are proportional. R1 and R2 are proportional because R1 is 5 times of R2. Therefore, 5 into 1, 5 into minus 2, 5 into 3. So, if it is the case, we have seen one more property. If the elements or the row or column are multiplied by a constant, then the determinant itself is multiplied by that constant. That means that's also a property, and we have taken out the 5 from the first row. Then we get 1 minus 2, 3, 1 minus 2, 3. R1 is identical to equal to R2. Therefore, the determinant value is 0. This is the property. Okay. So, by using the property 3 and 4, we have derived this. Okay. Now, I am going to introduce the property 5. Property 5 states that if the elements of a row or column are expressed as sum of 2 elements or sum of 2 numbers, then the determinant itself is expressed as sum of 2 determinants. That is the property 5. Property 5 states that if the elements of a row or column are expressed as sum of 2 elements, then the determinant is expressed as sum of 2 determinants. If the elements of a row or column, if the elements of a row or column are expressed as sum of 2 or more elements, if the elements of a row or column are expressed as sum of 2 or more elements, then the determinant is expressed as the determinant is expressed as sum of 2 or more determinants. This is the property. Consider the determinant delta. The first row of the determinant is A1 plus lambda 1, A2 plus lambda 2 and A3 plus lambda 3. Second row is B1, B2, B3. Third row C1, C2, C3. Here the elements of the first row are expressed as sum of two elements. Then this determinant is expressed as sum of two determinants. It is equal to, this is expressed as A1, A2, A3, B1, B2, B3, C1, C2, C3. Plus another determinant lambda 1, lambda 2, lambda 3, lambda 1, lambda 2, lambda 3, B1, B2, B3, C1, C2, C3. Like that, this, if the first row are expressed as sum of two elements, then the determinant is split into sum of two determinants. This is the property 5. It is very simple. If you expand along using first row, you will see. To prove this, I am going to expand the left hand side determinant using first row. Expanding the determinant using first row. Left hand side. Left hand side is using first row A1 plus lambda 1 into A1 plus lambda 1 into B2C3 minus B3C2. B2C3 as with expansion minus B3C2 minus A2 plus lambda 2. A2 plus lambda 2 into B1C3 minus B3C1. B1C3 minus B3C1 plus A3 lambda 3 A3 lambda 3 into B1C2 minus B2C1. B1C2 minus B2C1. That is, you multiply each element A1 into B2C3 minus B3C2 minus A2 into B1C3 minus B3C1 plus A3 into B1C2 minus B2C1. This is 1 plus this is one expression plus lambda 1 into, similarly lambda 1 into B2C3 minus B3C2 minus lambda 2 into B1C3 minus B3C1 plus lambda 3 into B1C2 minus B2C1. See, the first expression is nothing but the expansion of this determinant. A1 into B2C3 minus B3C2 minus A2 into B1C3 minus B3C1 plus A3 into B1C2 minus B2C1. Similarly, second expression is the expansion of the second determinant lambda 1 into B2C3 minus B3C2 minus lambda 2 into B1C3 minus B3C1 plus lambda 3 into B1C2 minus B2C1. Therefore, this is nothing but right answer. So, next you will get so the first expression is nothing but the expansion of the determinant A1, A2, A3, B1, B2, B3, C1, C2, C3 as second is lambda 1, lambda 2, lambda 3, B1, B2, B3, C1, C2, C3, which is equal to right answer. So, sum of two elements of the first row can be split into sum of two determinants. That is the property 5. Okay, that's all. Next. property 6. In this property, if the elements of the row or column are multiplied by a constant, if the elements of a row or column, if the elements of a row or column are multiplied by a constant or a scalar, if the elements of a row or column are multiplied by a constant and which are added to the corresponding elements of the corresponding elements of some other row or column. If the elements of a row or column are multiplied by a constant and which are added to the corresponding elements of some other row or column, then the value of the determinant remains same. Then the value of the determinant remains the same. Value of the determinant remains the same. If the elements of a row or column are multiplied by a constant and which are added to the corresponding elements of some other row or column, then the value of the determinant remains the same. This is given by delta as a determinant A1 plus KB1, K or KC1, A1 plus KC1 and A2 plus KC2 and A3 plus KC3. Next, second row B1, B2, B3, C1, C2, C3. The elements of the first row added with the elements of the corresponding elements of the third row are multiplied by the constant K. The elements of the third row are multiplied by the constant K and which are added to the elements of the first row. If it is the case, the value of the determinant is same. That is A1, A2, A3, B1, B2, B3, C1, C2, C3. This is the value of the delta only will get. See, in this case it is defined as delta. If A1, A2, A3, B1, B2, B3, C1, C2, C3 is given as delta, if the elements of the third row are multiplied by the constant K and which are added to the corresponding elements of the first row, then the value of the determinant remains the same. If it is delta, and after operating these operations, you will get the same value of the determinant. How we will see. By the previous property 5, this is what given determinant is A1 plus KC1, A2 plus KC2, A3 plus KC3, B1, B2, B3, C1, C2, C3. By the property 5, first row are sum of two elements, therefore the determinant is split into sum of two determinants. That is, A1, A2, A3, B1, B2, B1, B2, B3, C1, C2, C3 plus KC1, KC2, KC3, KC1, KC2, KC3, B1, B2, B3, C1, C2, C3. Like that, the determinant is split into two determinants. Because the first two elements are sum of two elements, therefore it can be split into sum of two determinants. That is again equal to, this is A1, A2, A3, B1, B2, B3, C1, C2, C3 plus this is 0. Value of the determinant is 0 because first row and third row are proportional. First row and third row elements are proportional. First two elements are proportional of the third row. The third row elements are multiplied by the constant k, which is again the first row. Therefore, R1 and R2 or R1 and R3 are proportional. By property, this determinant is 0. R1 and R3 are proportional. This is the reason. R1 and R3 are proportional, therefore this is 0 and this is equal to the determinant. Therefore, sum of the two, if the elements of the row or column are multiplied by a constant, which are added to the some other element, corresponding elements of some other row, then the value of the determinant is not changed. It remains the same. Therefore, we will get this answer. That's all about the property 6. Okay? Property 5 and 6 we have seen, and we have completed all the properties, and we will see the exercise in the next video. Thank you.